Hi, everybody. I'm Matt Pounsett. Along with Mike Baer at the back, I'm responsible for systems and network engineering at OARC. So I'm going to do a bit of a talk today about data that we have, how we manage it. So this is mostly DNS data, but things that are provided to OARC so that we can put it all together for people to do research on. It covers a lot of different things. But yeah, I'm going to give a talk about it basically from the infrastructure on up to the data itself. So this presentation, I'm going to be there. There are going to be a bunch of times where I talk about things I'd like to do, things we'd like to do. Sometimes it's things I'd like to do that others don't. The OARC, I'm sure you're all aware, works on fairly tight resource constraints on staff as well as capital. So there's tons of stuff that we would like to do that we just can't because there's or can't yet because there are other higher priorities. There's a lot of stuff that we think are great ideas, or might be great ideas, but we don't really know if other people would find them useful. So there will be a bunch of times in here I might mention stuff that I think we might want to do. If you think these are good ideas, please say so. We are going to try and do a survey this winter about the data we have and things we do about managing it and tools we provide and how people access it and what people want to do with it to try and get a better idea for those things. But if stuff comes up here that you think is important, please mention it to us at some point. It helps a lot to know whether the things that we think are good ideas or other people also think are good ideas helps us prioritize stuff. So the data stuff. So as Phil mentioned, we've been migrating our data infrastructure from the older set of 7 NFS servers that were all sort of independently connected to our analysis systems, which all had their own separate data on it, to a new Ceph cluster. So this is a clustered storage system. There's about 1.2 petabytes of raw data there, which with replication provides us with about a 350 terabyte volume that we can store data on. These are, by the way, these are all powers of 10 SI units, not powers of 2, in case that's important to anybody. So this is a large cluster of systems that have about 300 terabytes each, or sorry, about 130 terabytes each of storage on them. And Ceph is a clustering system that layers on top of that hardware to take care of replicating blocks of data across those servers, making things available, keeping track of where stuff is, and moving stuff around if servers or disks fail. Yeah, so about 130 terabytes per server, 350 usable terabytes of storage. Essentially, every block of data that gets uploaded onto the system gets replicated, so it's stored on 3 different drives on 3 different servers in the cluster. So if we lose any drive, lose any server, we don't lose data. In fact, if we lose any 2 servers or any 2 drives, we don't lose any data. One of the drawbacks, though, to this is an expensive system to run for us, and we have no way to replicate the infrastructure somewhere else. So there is no backup. There is the stuff that's in the cluster. So if we lose servers, that's great. If the data center is gone, the cluster is gone. One of the things restricting us on that is our data sharing agreement, which all members and anyone and most people who are contributing data to us also sign, which for historical reasons prevents us from putting data on systems that we don't control. The board has been looking at has had a privacy committee for a couple of years looking at making changes to that would allow us to do things like cold storage backup off OARC systems. Which would be a big help, but we're not there yet, unfortunately. And then in front of this storage infrastructure that we've got these 3 Linux systems, which we give access to members to on request to get access to the data that's there to do research, do analysis work. They're getting a little on the old side. I think the newest one is 6 or 7 years old. They're a little short on working disk. Most of them are pretty good for memory, but the older ones have the CPUs are not modern, that sort of thing. So we get a little bit of infrastructure constraints there for people trying to do work. And we also run into a bit of resource contention from people trying to do work at the same time, which unfortunately we can't really do anything about at the moment. But we do get people logged in there on a fairly regular basis. In fact, I had to institute a fixed maintenance window for those servers for the first time a couple of years ago, because it was getting to the point that I couldn't just reboot the servers when they needed a kernel update or something, because there was always work going on. So they're pretty busy systems. So on that data store, we have a bunch of things. So I've sort of divided this up into a few groups. So we have historical data sets here are things that we either used to collect or things that were given to us that we don't really expect these data sets to grow anymore. So the first one on this list is member-contributed DSC, which was originally around from about 2005, I think, is the first data for that. We originally had this DNS statistics collector system set up so that members could feed us DNS data from their own, or DNS statistics data from their own DNS infrastructures, and other members could look at that and cross-compare with what's going on their own servers and get an idea of what was going on in the industry in general. But over the years, people were less eager to contribute data to that, and it sort of fell by the wayside. We shut it down a couple of years ago. At that point, RIPE NCC, I think, were the only ones still contributing data to it. And also at that point, there had been no easy way to view the data, because the presenter that was in our old member portal went away when we switched to the new member portal. Nobody noticed, though, so we that contributed a lot to the decision to turn that off. We have logs and data from the old DNS testers that we used to run, things testing DNS message ID entropy and source port entropy and reply sizes. Those testers sort of became less relevant over time, so eventually we shut them down, and they've mostly been taken over now by the Check My DNS service. But we still have logs and things from when those were actively running. There's the DNS test beds. So for a little while, we ran an open validating DNS server back when before Google Public DNS or anybody else was doing DNSSEC validation. We ran a sort of semi-open validating server that members could use if they wanted to see how validation worked or wanted to test clients against a validating resolver. That not really relevant anymore, so that got shut down a few years ago. And similarly, we had a DNS privacy open resolver we were running for doing DNS over TLS testing, that sort of thing, which as it became easier for people to run their own servers, that also became less relevant for us to be running, so we shut it down. But again, we have packet captures and logs and things from those still hanging around. And then there's some derived data. So the example I've put up here is in 2013, when the work was being done on examining collisions in the DNS, trying to count how many people were already using .home in their networks, for example, before the first big round of expansions in GTLDs happened. There's a bunch of studies that were done on OARC systems, and we still have all sort of the derived data from people examining our PCAPs and producing new data from that. So that stuff is all still around. We have a bunch of ad hoc data sets. So these are things that are not routinely updated, but every once in a while people send us data and we add it to the data store. So we have PCAP data from non-day in the life events. So a good example of this is for about 3 years, there was an AS112 node that had the diddle capture tools turned on 24 hours a day and sent us data. So we've got 3 solid years of AS112 node data from one instance. I think that ran up until about 2017, something like that. And we occasionally have people send us query logs from things that are interesting. So we've got one from this case connections thing is from a US university that was running a fiber to the home network in their residences, I think. And they just every year they sent us the query logs from the recursive DNS servers from that infrastructure. So we have that kind of stuff there as well. And then we have our active collections. So these are the things that we're actively adding to all the time. So there's the zone file repository, where we grab copies of a number of the root zone and a number of TLDs on a regular basis, and store those. There's logs from the Check My DNS service. There's the RSSAC 002 stats. So so this is from the I always get this acronym wrong. It's the Root Server System Advisory Committee. So their advisory number 2 had to do with collecting specific statistics from the root server infrastructure. So all the root server operators generate these statistics every day, put them up on web servers, and we scrape those web servers and collect that data all into the same spot every night. And then we have our sort of our flagship chunk of data, which is the annual day in the life data collection, which I'm going to talk a bit more about now. So, day in the life. This is, the original concept of this was, yes, a day in the life of the DNS. In actual fact, it's 2 days. We do a collection for 50 hours every year in the spring. And this is most of the root operators, a number of TLD operators, mostly CCTLDs, but I think we have 1 or 2 GTLD operators contributing right now. And new this year, we have a big recursive infrastructure from a university in Brazil also contributing. So it's PCAPs for 50 hours straight from the DNS infrastructure of the contributing organizations. It's 50 hours instead of 48 in order to give a little bit of fuzz at the beginning and end of that 2 days. We get we just get a stream of PCAPs in from the operators. It takes us about 2 weeks to actually collect all the data, but we have this going back to 2009, 2010, I believe was the first one. My graph here just has data from 2014 because that was an easy date range to grab info from. But you can kind of see how the data volume that we've been receiving from people has grown over the years, despite the fact that the number of contributors has been fairly constant. So right now we're getting 12, 13 terabytes of data from a collection from around 20 contributors. So how does this work? So this starts with a set of tools that we give to contributors, although there are a few contributors who have sort of rolled their own, particularly larger organizations. But DIDL tools, it's mostly a set of shell scripts. There's some C code in there for if people want to use TCP dump. But essentially it manages running DNS cap or TCP dump to collect data off your DNS server, dump it into a queue that a submit script loops over, and as it processes data in that queue, it streams that over SSH to servers at OARC. When we receive that, each contributor has a login on our capture servers, which runs a custom shell, and that shell knows how to accept data from that submit script that sends things in a particular format, to include a bit of metadata, checksum, and then the actual data of the individual PCAP file. That shell takes the metadata, such as who the contributor is, a little bit of information about where it came from. So we accept things like a node name in that metadata from the contributor, and timestamp on the file, and then saves it off into a location on our systems, which becomes part of the DIDL, what we call the raw data set. So this is compressed PCAPs as uploaded from contributors. Once the DIDL collection event is over, we make that raw data set available to researchers as is. There's also an older post-processing process that was set up that does some normalization of that data. So it does things like recompress everything so that it's all compressed with the same compression format, reorders packets in the PCAP files, Berkeley packet capture does not guarantee order in data written to a PCAP file. So we reorder the PCAPs by timestamp and then also resplit the files so that they all split on the same 10-minute boundary. The idea being that this makes it a lot easier for researchers to compare like to like when they're comparing data from different contributors who may be splitting their PCAPs on 5 minutes or 15 minutes or half an hour or whatever they're doing. There's a few other things that happen in there as well, but then that produces what we've been referring to as the clean data set. We haven't run that for a couple of years now. It was not behaving as expected anymore. We haven't tracked down exactly why, although we suspect it's new behaviors of the DNS not interacting well with the older tools we were using to do all this. And the end result was that we were throwing away data we didn't expect to throw away. We expect to throw away things like ICMP. We expect to throw away answers, but there was more data disappearing from the data set than we expected. We put out I've written a bunch about this on the members mailing list over the last couple of years. We're trying to figure out how we can spend some time to go over this process and clean it up, make it work well again. But it's one of those things where we're not really sure how useful that is to people who are doing research on the data. So this is something we'll include in our survey later this year, but if people have opinions on that, we would love to hear from you. And then there's also some metadata that we used to generate are not at the moment, which is things like a coverage map that shows which contributors have contributed data for what time periods during the capture, general volume of data we're getting from everybody, that sort of thing. The tools for that depend on some old Perl, which depends on some older Perl modules, which we can't install anymore, and there's some updates that need to occur to that we just haven't had time to do in order to make it installable and runnable on a modern system. So that is a thing that we do plan to fix up, but we're just not exactly sure when it's going to happen. And circling back a little bit to the diddle tools, there is some stuff in there that needs updating. The tools, when we do get new contributors on, it requires a bit of hand-holding for most people to get that up and running. This is a case of, the operating systems has marched on, but the tools haven't really been updated in a while. And so there are a couple of operating systems where there require some manual tweaks to the makefile to get the TCP dump splitter to compile. And the instructions aren't, don't necessarily work well for where applications are installed on systems these days, that kind of thing. So there's a bunch of stuff in here that needs some love and care, and we're kind of trying to decide where to put our attention on those things. That is how we get this data. How do you get access to OARC's data? If you need to be a member who has signed the data sharing agreement. I forget exactly when, but several years ago we split out the data sharing agreement from the regular member agreement so that members who didn't want to access our data didn't have to agree to all the stuff that's really only meaningful for accessing our data. So your member organization has to have signed the data sharing agreement. You need to have a contact in the OARC portal. And with those two things, if you upload an SSH key to your profile in the portal and then ask, we'll create a login on one of the Unix servers for you and you get access to things. You can get anything I've mentioned here plus more. There's other stuff that sort of fits in the categories I've mentioned that I haven't specifically mentioned the data. There's all kinds of that stuff there that you can get access to. Now, using the data, this is one of the things that we're not super happy with the way things are. So exactly what you want to do to use data is really highly dependent on which data you're talking about and exactly what it is you want to get out of it. So it's hard for me to give an easy answer here. But there are some issues here. So there's not really a lot of documentation or help about that. We've, with the new Ceph cluster, where the data is a lot better organized now, and we're still making some improvements there, moving stuff around, taking data that fits in the same category and putting it in directories together, that sort of thing. stuff that wasn't really possible when we had all these separate NFS servers. But there are so there's not a lot of documentation. The processing capabilities we have in the analysis servers are a little bit limited. I mentioned that earlier, but we are trying to work on these things. So that is kind of the coverage of all of this stuff. One of the things that we are working on is some better tools for doing quick and easy analysis of data, and Jerry's going to be up to talk about that in just a minute. But if there's anything else that people have questions about here, I'd be happy to answer them.
For questions?
Yes.
Hi, Dwayne Wessels from VeriSign. Thanks a lot, Matt. So there is some the webpage on the OARC site that talks about diddle data. Has lists collections going back to 2006. I haven't seen those files for a while. Do you know if those are just gone or are they still around somewhere? Is there hope of getting those back?
Yeah, there are. This is one of the unfortunate effects of the way this was stored on sort of disparate NFS servers before. I know this isn't news to you, but I'll go through the background a little bit for other people. The way this was originally set up is that we had, there originally was just one NFS server, but then there was more data, and so then eventually there were 7. The way we were dealing with data resilience there is those were all using either RAID 5, RAID 6, or ZFS to protect the data on the server. But to protect from server loss, we would take any data set that we had and store it on 2 servers. That used up a lot of storage, but it worked pretty well for a while, until around 2018 or 2019, when we had 2 NFS servers fail in quick succession. So there are a number of data sets that were only on those 2 servers. One of them is dead. We're not getting it back. The other, we're pretty sure it's just like a memory or CPU problem, but it failed during the pandemic, and we were not able to go and do anything about that at the time. We are just on the verge now of starting work on recovering that second server, which should give us access to those data sets. There is an offsite copy of most of those in Ottawa, which we can still access. Yeah, I think there's only 3 data sets that we cannot access at all right now. But we're resisting copying stuff from the Ottawa site to the Fremont site just because of the amount of time and bandwidth that would take. So we want to establish whether or not we can recover that other NFS server first, and if we can, that gets us access to all that missing stuff, and then we can add it to this Ceph server. If we can't, then we'll move what we have from Ottawa onto the Ceph server, and unfortunately, there's these 3 data sets that we will just lose in that case.
Okay. So what I would find helpful is like for all those historical data sets, if we could have some sense of, we think it's gone, or we think we can get it back, or we're working on it, because I have things that I would like to go back and look at, and I would find it very useful if should I just stop thinking about it, give up,
right.
or still plan on doing it in the future. So.
Yeah. Okay. Yeah. That would be pretty easy to do. I'd certainly to drop a README or something in with the rest of the diddle data to indicate where that stuff is and what the status is.
Thanks.
Yeah.
Hello, Jeroen Bulten, SIDN. I don't believe we're submitting PCAPs yet, so maybe we should. You mentioned in your presentation a set of tools for pre-processing PCAP files to get them all in the same format, same type of compression, etc. Are those tools publicly available as well?
So yes and no. So the C code that does most of that work is stuff that Dwayne maintains as part of, I think that's still with Measurement Factory, isn't it? The PCAP tools package? Yeah. But it's all wrapped together with a shell script that is very diddle specific.
Right.
And there's not really a lot of point in sharing it unless somebody's trying to help us clean up our cleanup process. It wouldn't really be useful to another organization.
Okay.
you could, yeah, if you were interested in doing things like reordering and recompressing and things like that, it's just, yeah, I could point you to the PCAP tools that Dwayne wrote, and the rest is just, yeah, shell scripting around, gzip and stuff.
Okay.
Yeah.
Thank you.
Yeah.
Hi, Yaroslav Kolomic, Meta. So also a question about pickup files, yes. So you mentioned that you include a step to reorder them in order of timestamps, right? So about the timestamps, since they are contributed by a different like uploaders, right? So large distributed system, yeah. How do you know those timestamps are anywhere accurate? Like how do you validate that the source systems are actually synchronized to true time, like whatever it is?
Yeah. There's no way that we can make absolutely certain that other people are synchronizing the time on their servers. It's not possible. We trust that our contributors are doing that. It's part of the setup instructions. It's part of the checklist of things we ask them to look at before a capture. But there's no way we can verify that the time on somebody else's server is accurate. Berkeley Packet Filter guarantees that the timestamp in the file will be accurate as to when the packet showed up, and we are relying on that for the reordering of packets inside a PCAP file.
But still using the timestamp of that source system, right?
Yes.
If it's synchronized or not, you cannot tell.
No, there's no way for anybody to know that.
Yeah, so if anyone uploads pickups from 1970, you just accept it.
Well, if their server in 1970 had the date set to the window for the diddle collection in 2025, sure, we would accept that. I don't know why that would happen, but yeah.
Right, cool, thank you.
Hi, Roy Adams, ICANN. Here's a tip. If you want to synchronize things, set a probe to everyone who contributes data. Right, all of the name servers, just simply send it a query that you can then later use to synchronize all the PCAPs.
That only works if we know what the internal setup of their infrastructure looks like. So for example, Fruit sending us data, there's no way I can send a query to every Fruit node. I can't. It's like there's no mechanism where I can guarantee that's going to work.
Due to Anycast.
Yes.
Yes. No, I get that.
Or not, but not just due to Anycast, right? If there are, if a particular Anycast instance has multiple servers at it, I can't send a query that's going to hit every server in that instance.
No, but I do think that part. I mean, what people do internally in their organizations, you kind of hope that things are synchronized there.
Yeah.
But if you want to synchronize between the members who donate their data, right, you could send them an individual query and then synchronize on that query. Or just see if the synchronization is off with the timestamp that's in the file. It's a simple trick. I mean, we do it.
It's simple in concept. I'm having a hard time picturing how that works across organizations, again, when we don't know anything about the internal setup of the contributors' network.
All right. Let's talk afterwards.
Yeah.
All right. Cheers.
Yeah.
Thanks. Thank you, sir.
Raffaele Sommese, University of Twente. I have a question regarding another dataset that is the zone file collection that you run here at the DNS-OARC. And my question is in terms of data sharing of that dataset, because that's the dataset can be shared beyond the single ARC members if they have access already to the zones.
No, generally no. The only zone in that data set that's not encumbered by some kind of confidentiality or licensing agreement is the root zone. Everything else, or almost everything else, comes from ICANN's CZDS system, which requires you to basically maintain that for personal use. You're not allowed to reshare that data. So we do make it available to members who have signed the data sharing agreement, but they are not allowed to take it off of our systems. If they want to have that data themselves, they need to go sign up for CZDS themselves.
No, I agree on that. What if they have access already to CZDS? So if the members have access to CZDS, can they then export the data?
No, well, because we can't police that.
Okay.
We're not going to try and police that. The licensing agreement that we have says we will not reshare that data, and so we don't.
Okay, perfect. Thanks.
Yep. All right. I guess if there are no other questions, then I guess we'll get Jerry up here to move on to the next bit. Thanks, everyone.